Hey everyone, so this is our second stage of cellular respiration, and this is our Krebs cycle. All right, so what I want you to remember at the end of glycolysis, right? At the end of glycolysis, we produced two molecules, all right, two molecules of pyruvate. And so prior to the Krebs cycle starting, all right, so down here it says prior to the start of the citric acid cycle, there's a very fundamental process which involves the oxidation of pyruvate. Now remember, the oxidation means loss of electrons. And as electrons are lost from pyruvate, it's converted into a molecule called acetyl-CoA. All right. So essentially what's happening here is we have this pyruvate. It undergoes oxidation, and so therefore it's going to lose its electrons, and it's going to lose electrons to this NAD+. So here's our electrons, right? And as NAD+ picks up those electrons, it picks up two electrons and a proton, NADH, right? So there's our H. And what happens is if you look at this molecule over here, this acetyl, all right, acetyl-CoA. So essentially it's this acetyl group with this CoA piece attached. And this is two carbons, this acetyl group, two carbons. But look, we started with three carbons. Well, things can't just disappear. So guess what this is? We produce a molecule of CO2. But what we have to keep in mind is that we're going to start with two pyruvates. So that means we're going to multiply this all times 2. So we have 2 NADH. Oops, sorry. We have 2 NADH produced with our electrons. We have 2 molecules of CO2 produced. And again, we get 2 acetyl-CoA. All right. So from there, it's pretty straightforward because we're not really going to go through all the reactions of the Krebs cycle. We'll watch this video as kind of a summary to see in class tomorrow. This is ultimately the citric acid cycle. And so what we can see here is here's our citrate, right, which is the anion of citric acid. And so what happens is here's our acetyl-CoA. It starts the cycle by combining with this substance called oxaloacetate. And again, we're not going to need to know all of these names, but what we want to pick up on, the important things are seeing that we get more CO2 produced and we're getting more of these NADH molecules and this FADH. So a whole bunch of reactions, right? I mean, we could look at each one. We got, if we count them, so we've got 1 starting the reaction to produce citrate, 2 gives us this isocitrate, and then so on and so forth. 3rd reaction, 4th reaction, 5th reaction, 6th, 7, and then 8, and we're back to the beginning, ending up with this oxaloacetate. We don't need to know all 5 reactions. We don't even need to know all these individual molecules that are produced, but what we, that are used and formed, but we do need to know the FADH and FADH2 and the ATP. So what we get out is we get 2 NADH, we get 1 FADH2, and if we count We got an ATP being produced here. We got 1 ATP. But what we have to remember, how many acetyls are we going to get? Remember, we had 2 pyruvates, so we're going to get 2 acetyl-CoAs, and the cycle is going to go around twice, so therefore we multiply these all by 2 to get our total numbers, right? Oh, and I think I missed an NADH, sorry, up here. I missed that, sorry, there's 3 NADH, but the one missed at the top. And it doesn't get much simpler than that, that's it. But let's focus in again, we get, as far as waste goes, right? We end up producing 2 more CO2 molecules, right? 2 more CO2 molecules, and that means we produced 2 CO2 molecules up here, and we produce 2 in the cycle, but the cycle goes around twice, so that means we produce 4 molecules in the Krebs, but we also had 2 molecules from the step prior, right? So what does that mean? We have a total of 6 molecules, 6 molecules of CO2 are produced. I want you to think, pause the video for a second, think of the balanced chemical reaction. See if you can write the balanced chemical reaction down on a piece of paper. Pause the video and then start it again. Well, good practice to be able to write the balanced chemical equation for cellular respiration. And what do we see? 6 molecules of CO2 produced. And that's it, short and sweet. We'll fire up with the electron transport chain tomorrow.